Welcome to Chem Help ASAP. We're going to talk about why bonds form. It turns out bonds form because it's energetically favorable for bonds to form. And ultimately, we'll have to talk about orbital diagrams, which are ways to describe energies of bond formation. So why is bonding good? And people say that it's a good thing to form bonds. When they say good, they're not talking about good versus evil. They're talking about good energetically. So good is a way we describe things that are energetically favorable. So why is it good? Well, we talk about the octet rule. Bonds help us satisfy the octet rule. And that is certainly a good thing, an energetically favorable thing. But why are bonds inherently good? Well, let's look at a molecule, H2, and when we think about these electrons, we have a nucleus, and that has a proton in it, and another nucleus, and it has a proton in it. And what we're doing in making a bond is we're letting electrons sit between these two positive nuclei. Now, if you're an electron, where do you want to be? You want to be between positive centers. You don't want to be around just one positive center, which is really what we have with atomic hydrogen. But you get to be between two positive nuclei. So that's a lower energy state for the electrons. And when we talk about energy, we're talking about energy of electrons. We don't care about the nucleus. We talk about the electrons. So this is why bonding is good. How do we describe bonding? Well, we tend to draw orbital diagrams. So all of our orbital diagrams will look something very close to this. We will draw two lines, one on the left, one on the right. These represent our atomic orbitals. Now for a hydrogen atom, this might be a 1s orbital, but it could be any atomic orbital. And almost always our atomic orbitals have a single electron in them. So this is kind of the before state, before we make our bond. Now, we kind of move in time towards the middle. So as we move these atomic orbitals together, they mix. And our two atomic orbitals form two new orbitals. So this is the after. As it turns out, one of the new molecular orbitals tends to be lower in energy and one tends to be higher in energy. And this gives us a bonding orbital. And our higher energy is an antibonding orbital. Now notice, once this occurs, the atomic orbitals are gone because they've been used to construct these new molecular orbitals. Well, what happens to our electrons? Our electrons go down in energy. So the electrons fall down to the lowest energy state that they can. And so we had two electrons that just dropped in energy. And when we draw these orbital diagrams, we typically have an energy axis, and I've drawn that in the middle of the screen. Now, people don't always label it energy axis. Lots of times they'll just put E at the top of the arrow. But what we've seen based on energy axis is that our electrons have dropped in energy, and we're reflecting the fact that this is a good thing. It's an energetically favorable thing for these electrons for our atomic orbitals to mix together, form new molecular orbitals that allow our electrons to drop in energy. So this is why we form bonds. We form bonds because it's energetically favorable to do so.